Christophe.
Hello.
Welcome back.
Okay, it's working.
Yes, it is. You can
Yeah.
share your slides. Hello, everyone. Hi, Marcelo.
Hello, yeah.
Is
The
everything
webinar
okay?
has been, yeah. Actually, you have been starting the webinar already, right?
I did.
Yeah.
Because I wanted to let Christophe in.
Sorry?
I wanted to let Christophe in.
Yeah, that's fine. Please move on. You can actually, we should wait 1 minute before start because people are still on the main stage.
Okay.
And then you can, in 1 minute, you can start speaking, but we are live already, okay?
Okay.
Perfect.
Thank you. Have a great session.
Thank you. Good morning, everyone. Can you send us an email, a message in the chat to tell us that you can hear us?
Ça marche plus.
Thank you, Elisa. It's working. Thank you.
Okay. Ready.
So we have a few people online, Christophe. We'll wait 1 more minute, maybe?
Yes.
You tell me when you want to start.
Yeah, let's wait 1 minute for people to switch from the main stage if they want to come. Okay.
It's okay. You think we can start?
Yeah.
So welcome, everyone. Christophe and I are in France. Christophe is the president of Proditech, a company that is making automatic quality inspection equipment for the industry. He's also the president of the French Lean Institute. He will use the example of the latest company innovation in terms of inspection to talk about how Lean and Jidoka has transformed his company. Christophe, you can start.
Thank you, France, for the introduction, and hello, everyone. Yes, I would like to talk about Jidoka today because when I'm in the different companies, what I can see is a little bit different from what I expect in terms of TPS that you can see. Every time I go to a customer or another company, I see that the pillar of Jidoka is not every time well implanted, or there is more focus on just in time. If you read articles, if you read books, a lot of books are talking about just-in-time flow, accelerate the flow, but not a lot of articles are talking about quality and Jidoka. So it's always it's often referred as a forgotten pillar. So let's take the example of my company, Proditech. As Florence said, we are making high-speed automatic quality inspection machines for two main industries. The first one is the minting industry. As you can see, we can inspect blank and coins at very high speed, very high precision on the production lines. And we can also, on the pharmaceutical side, inspect tablets and capsules at large pharmaceutical manufacturers like Pfizer, AstraZeneca, all the names you know. So Proditech is a SMA company, 50 plus people. We have customers in more than 57 countries. So a lot of exports. We are based in France, in Europe, and we are a high technology company. We're using a lot of software, hardware, electronics, electrotechnics, mechanics. So a lot of components that makes the complete systems. So I will start from the past, and for more than 25 years, we thought we had the perfect business model at Polytech. Basically, we saw our company as an engineering company, making design, inventing machines, and then we externalize everything else. That means part manufacturing, assembly, purchasing, logistic was externalized to a subcontractor. Basically, that means one order placed, we received one finished machine, and then we could test the machine, send the machine to the customer, and install at the customer site. So the dream fabless model, a lot of advantages on the paper. Of course, no investment in fab manufacturing. We can change the supplier if we are not happy, and it's very easy to operate in terms of administration and finance, only one order to manage. But the issue is really the quality. At that time, we experienced a lot of issues. I refer the quality hell at Polytech. It's not that we were not making efforts on quality. On the graph, you can see here the cumulative cost of non-quality. We made everything that was requested, recommended, like ISO 9001. So the quality costs were decreasing, but every time we had a new quality accident, raising the cost very high. And this type of accident was not predictable. So we worked hard on improving quality, and then bing, a new quality accident. So it came from the electronics first, can come from the mechanics or the electric components. So we made a lot of things. Every time we had an accident, we did something different, like reorganization on the company, hiring new people. But from one time, you don't know what to do because it's always happening and you never know when it's going to happen. So it's very complicated to manage, especially when you sell quality inspection machines. How do you make quality equipment, quality products? And when I look at outside, it's the same. I see all the big companies, they have the same. They have very huge quality accident, like the last one with Boeing, Windows, Takata, it's the same. And in the pharmaceutical industry, a lot of drug shortages are due to quality accident also. So what to do? I didn't know what to do. So in 2011, I chose to engage the company in the lean journey as a survival business strategy, because I didn't have any clue about anything else that could help me to solve this problem. So of course, we are a quality company, so we were really interested in Jidoka, which is mainly for quality. And but it's kind of complicated to understand, at least, in fact, easy and complicated. When I look at the definition of Toyota, it's called the first pillar of the TPS. And it can be translated in how you make automation with a human touch, which is some kind of difficult to understand. Stopping immediately after when abnormalities are detected. It's kind of easy to understand. But when I look on the internet, Wikipedia, Jidoka, there is nothing. It's redirected to automation. So the problem is, where to start? Sorry. Okay. Sorry. So the problem is where to start and what Jidoka means in your context. For example, Polytech is manufacturing 15 to 20 machines per year. So we don't have a moving production line. It's not high flow. So there are a lot of concepts, Pokayoke, Andon, zero defect, automation, but how you apply these concepts on your own context, that's the main point. So first, we decided to work on detection capabilities, and we changed one point, which was the batch order. we used to order 4 machines at a time, mainly to benefit from a discount from the supplier, of course. And we changed that, doing only 1 order at a time. That means we stopped having the discount, but we thought that it was more important to change the flow to really be able to reveal anomalies on the flow. So no inventory, and so you have to take care of your problems. And then the first big problem appeared. We had an Indian customer doing a factory acceptance test. Everything was running properly for 3 days, and the last day, almost at the last hour, we had an issue on the machine. One capsule was not ejected properly. So everyone saw the problem, but the problem appeared only once. So everyone in the room said, okay, it's not so important, so we can continue, we'll see that after. And I had to intervene in this project, in this process, to say, okay, no, we want to do Jidoka, so we want to stop at the defect. So I'm here, I'm the CEO, and I will stop the delivery process. And it was not an easy task, because the customer said, okay, I want the machine, I want to get rid of the manual inspection, I need the machine. So you'll fix the problem later. And the agent was doing the same. So I had to said no. I had to manage the unsatisfaction and said no. We have to fix the problem before shipping the machine. So that means we had to change behavior to really show our commitment to the quality. So it was difficult because I had to negotiate with the final customer. He was dissatisfied, and I had to manage immediate dissatisfaction, really to ensure long-term satisfaction. That's what happened. We fixed the problem, and then we shipped the machine. It worked perfectly, and the customer was happy at the end. Another example is after this, after some years, we decided to change the business model and really to internalize the assembly operations. So that means we bought the parts and assembled the machine by ourselves. So we had to create a purchasing department, logistic department, assembly department. And basically to assemble a machine, it's 5 weeks assembly. So in order to work on detection capabilities, we decided to really detail the work content and transform the 5 weeks assembly into 175 hours of assembly. So we had to change the flow once again to reveal anomalies. So what happened during the day? We had now a mean to have a daily work content composed of 7 hours of assembly. And every day, at the end of the day, there is some time dedicated to deliver the work of the day. So that means we offer the people to stop at least once a day. For each hour of assembly, they can tell, okay, this was okay, this was not okay for this reason, this reason, this reason. So we have a system to stop at least once a day. I recall that we don't have a moving line, so it's a very, very slow process to assemble the machine. So once again, we have a system to change behavior to show commitment and quality at the people side. Oops, sorry. And there it's the same. We always have to manage immediate dissatisfaction of the customer, in this case, internal customers, to ensure long-term satisfaction. So we have the assembly team has to deal with the project team, which is waiting for the machine. They need the machine to finish and the project and deliver the machine. They also have to discuss with the dev team, because the dev team has to modify some points to restart when the assembly team stops. So it's a lot of collaboration internally for the internal and internal customer, internal supplier. So another example, last year, we decided to apply this principle to our product line. If you look at the Jidoka level, you can have all these different levels. We can start from workstation, sales, department, the site plant, and the external customers. And really the objective is to prevent outflow of defects throughout this team. And when I look at my products already, the quality inspection machines are coming after the almost the end of the process, the pharmaceutical process. So it's Jidoka because it can stop the manufacturer to ship bad products, and really they can prevent quality accidents at external customers. So to be able to do better, maybe we can think of a different system to be able to detect defects at the workstation. So we set up a new project called Koji, totally different systems, technological system, with the aim of putting one quality inspection system at each workstation, really to be able to be closer at the source. So the same, how can we change the flow to reveal anomalies and prevent quality accidents, but at the internal customers, not only for the external customers. So if I look at traditional systems that already exist, it's called traditional vision systems. And it's always the same for the last, it has been always the same for the last 20 or 30 years now. You have to assemble the technologies, you have to integrate the technology on the line, and you start from the customer requirement, say customer requirement on specification, system or software requirement specification, and so on. So that means at the end, you have this project, and this project is tailored to the specific needs. And this is very difficult to do at a large scale, because if you want to put systems everywhere in the company, you have to go through this process all the time. So what we think we can use this new technology, at least right now, with the new power of computing, AI, for applied to vision systems. And not every type of AI is good for this type of application. Here we have the opportunity to use what we call unsupervised learning, which means that you don't need to show the defects to the machine. The machine is trained with good items, I will say. And every time there is something different, the machine will say, okay, I don't know what is different, but I know here that there is something different. So I can raise a tag and say, okay, this is the anomaly from what I've learned before. The other challenge for us is not ChatGPT, where you can use massive computing power. You have to do that real time. That means you have to use edge AI, meaning the computing power must be embedded in the system. So I can show you here, oops, sorry, I can show you 2 videos. So very simple systems that we have started to implement. So the goal is really to remove all the integration work, at least to be able to, for the customer to integrate the system by himself. So easy to integrate, easy to configure, easy to operate, of course, accurate enough, very flexible, because when you change product every time, you don't want to code the new algorithms for the vision system to be able to detect defects. It needs to be robust and low cost. So in this slide, for example, you see on the bottom the defects, which is the missing components. At no time in the system we have teach the machine to recognize that there is a missing components, but we have taught the system to be able to recognize what is a good one. So there, the system will say, okay, this is different from the normal. So this is an anomaly that I can show you. So if we work on reaction capabilities now, you have heard about the mechanical undone from Toyota, the original one on the loom. And then with this type of system, we have created an AI-powered digital undone, where we get the data in terms of reaction. We have an undone plus the data to analyze the undone. So this will help also the customers to change his behavior, to show the commitment on quality, the same. So really to summarize, at Proditech, looking at Jidoka and trying to really understand what Jidoka is in our context has made a lot of changes. And it's really strategic changes, I would say. And for me, we have succeeded to make the company stronger. First, on quality, we have internalized the purchasing, logistic, and assembly department to really understand what is the quality level and what is the quality on our product. The second one is on innovation. We have now starting to make a new product with AI calling digital engine. And this has been done through people development, really. That's the key here. So if I take a little bit a step back, I would say, for me, Jidoka is really at the heart of Lean. And it's not only tool, it's really a mindset and tools. So if we think Jidoka, that means we have to think about anomaly management, how I manage all this anomaly. And first you have to detect. So you have to detect anomalies. So you have to build the capability with the people and then with the machine, how to detect anomalies. And then you have to build also capability with the people and the machine on how to react to the anomaly. So it's really a people development task that is made first from cooperation through negotiation with internal customers and internal suppliers first. So it's really important to understand that the people are, every time we see that in Lean, but there it's very, very important to understand Jidoka as a people development tool. And then, of course, you do that to be able to do Kaizen and to change the main things on the company for the benefit of the external customers. So when you see Jidoka like this, you can start to use and to understand better all the terms and concepts that are developed through the Jidoka concepts, like abnormality, quality at the source for detection, and on the problem capabilities on the reaction, learning also. And Kaizen, you can use Kaizen for automation, for Pokayoke, error-proof systems, and then innovation, with the final goal of having 0 defects to the external customers. And if we come back to the TPS, we can also see that there is a model where just-in-time is really at the service of Jidoka. And remember, Jidoka was considered as the first pillar in the definition of Toyota. And why is that? If you do only just in time, of course, you have some benefits on the company, but you miss a lot of benefits, which is to feed the Jidoka pillar. So if you change the flow, you can reveal the anomalies. But what you do with the anomalies, you have to change your behavior to really show commitment on quality. That means being able to detect and to react to the problems. And then the last point is, if you see Jidoka as a risk management systems based on anomaly, you can not only use Jidoka on quality, you can use Jidoka on all the values that you want to deliver to your customers. I would say safety, quality, lead time, cost, energy, and connectivity. Because it's a system to decrease accident risks. First of all, to reduce the losses, then to learn, and then to be able to make changes to seek for gains. That's a process you can apply on every value that you want to deliver. Okay, I think we have time. Was a little bit quick. We have time for the questions.
Yes, thank you, Christophe. That was a great presentation. We have a few questions already. Alex is asking, he's saying it's very interesting, and he says, who is involved in the quality process? For example, who is involved in the work on reaction capabilities? Is it the production that is involved?
The way we see Jidoka, it's for the entire company. There is no, I took the examples, of course, on the production side, but you have the same if you look at the R&D teams, for example, it's exactly the same in their field. That means they have to deliver something, but before delivering, they have also to have the capability to detect errors, for example, software development. We need to build the capability with the people to be able to detect what is a bug in the software and not to deliver the bug to the internal customers. So that means, for example, to the production that is going to use the machine. The production is the first customer from the R&D because the R&D is giving all the software and the drawings. So if you think like this, there is no particular area where you have to apply this. You have to apply this everywhere. Of course, somewhere it works better than the other parts, and you see your company in terms of capabilities. Okay, in this department, the capability is very high. In this department, the capability is starting, it's improving. This one, you have new people, for example, you have a lot of turnover, for example, so you have to build again the capability. So it's always a goal to have the right level of Jidoka in every department of the company.
Okay, thanks. We have 5 more minutes and we have more questions. Billy asks, with the system being fairly new to your business, have you experienced any instances where the AI inspections have not detected a problem and this has led to problems further down the value stream?
Okay, so that's a good question. I don't have the history right now to answer to this question, but basically we are installing the first systems right now, so we don't have the history to say that. But the idea is to once again to help the people on the field to be able to improve their detection capability. So that means it's not a system to replace people, it's a system to enhance the capability of the people. So that means if we put this type of system, we don't get rid of all other people, all other processes, all other quality systems, but we need to enhance the capability of the people to be better at detecting. So in the case, for example, the system will miss something. Actually, what we look at, it's not this. It's we look at how many times the system has helped improving. So maybe the system is not 100% accurate, but if you don't have the system, you have 0% accuracy. If you have the system, if you have 90% accuracy, you have helped and improved the Jidoka capability.
And Joseph is asking, how fast is AI engine able to check final products in terms of cycles per minute?
Okay, so for example, right now, the first system is able to have a cycle time of 1 second per product. And the real issue, technology issue is because we have to embed the AI inside the system and we have to maintain the cost low. For example, we cannot embed the latest generation of NVIDIA system, which costs only the chip is costing $20,000. This is not possible. So we have to try to find the right balance between the power and the costs. And of course, we know that the story is already written. It's always more power for less money. So it's the same. The system will improve to go faster and faster over the time where we have the right processing board and also the model, the AI model right now, it's evolving at a very high speed. So we have to choose the right model with less consumption, for example, less consumption for the power to be able to go faster and faster. So that means that the first time we find some application compatible with our speed, and then we can go to more and more application. But once again, if we have this system and we are only able to only check, let's say 60% of the products, we are not doing 100% inspection, but once again, we are improving the detection capability. Instead of having one person staying in front of the line, which is not possible, we have one system that is checking in real time 60% of the production. So you increase the chance of detecting the anomaly. This is the philosophy that we have.
Okay, I have 2 more questions, but only 1 more minute. So when installing AI, you detect more waste than before. How do you deal with that? Is it really waste for the customer?
So that's a good question. Once again, we come to the reaction capability building. So the system will tell you, okay, there is an anomaly, but it doesn't tell you this is a problem. This is a quality problem. It just tells you, okay, come and look. So the people will still be in the loop to say, okay, there is an anomaly. From my point of view, it's not yet a problem. So I can run the line. I can still run the line, but I have to react accordingly to what I think is the problem. Is it going to be a problem in 10 minutes? Is it going to be a problem in 1 hour? Or is it going to be a problem now? So the reaction capability still need to be built with the people.
Thank you, Christophe. I'm sorry you have to stop
Okay.
because it is 11 now. If you have more questions for Christophe, please find him on LinkedIn and send him the questions directly.
Thank you.
Thank you, everyone. Have a good day.